Hey, welcome back, class. Welcome back to another episode of Math 1 Distance Learning. So, this is actually part 2 to my lesson on Introduction to Slope. So, hopefully, you have already watched the video part 1. So, I'm going to review just a little bit and then we're going to get into those notes. We didn't get very far into the notes. So, you should have the notes in front of you. Intro to Slope notes, got Bart Simpson at the top. So, let me go ahead and flip over to my PowerPoint. I'll review a little bit and then we'll get going. So we started off, so the objective for this lesson is to be able to find the slope of a line from a table or a graph and be able to use rate of change to solve problems. So I gave you a definition of slope. We said that it is the measure of the steepness of a line. So we talked about a line. I used the example of a ruler. So this is a flat line. So this would be a slope of 0. But then if I started to tilt that slope, now the slope is going to change. Okay. And if you look at the two slopes, the two lines on the screen here, the red line is at a steeper slope. So the slope is actually going to be a bigger slope. So it's a steeper slope. And we talked about slope being a ratio, a fraction of what we call the rise over the run. And we're going to get into that today and you'll see what the rise and the run are. And we said it's the y over the x. So we're going to travel along the y-axis and that will be our rise, whatever number that's going to be. And then we're going to travel along the x-axis, and that will be our run. And we said slope, it's the same as rate. So when we're doing word problems, we don't call it a slope. In a word problem, we call it a rate. $12 per hour, $8 per hour, 3 chocolate chip cookies per day, right? That's called a rate in a word problem. But when we're doing it mathematically or looking at a graph, we call it a slope. Okay, so that's what we're going to be working on. We looked at some examples of slope in nature. We looked at some examples of slope in real life. We talked about roller coasters and water slides. And then we looked at like freeway overpasses. This was a street that's one of the steepest streets in the world. We looked at skateboarding, this mega ramp from the X Games. And then we also looked at some careers. Where are those careers? Careers, we've talked about construction, right? For example, building a ramp for a wheelchair ramp, a disabled, a handicap ramp. And we talked about being an architect, uses slope. And we also talked about financial market analysts that work for banks and on Wall Street and stockbrokers. They need to have a good concept or good understanding of slope. Okay, and then we talked about positive and negative slopes. So I'm just going to click through these quickly. If the slope is going up, we always read graphs from the left to the right, like we read a sentence. We start on the left and we read to the right. We do that with graphs, and if it's going up, positive people take you up, right? So that would be positive. And if the graph is traveling in a downward direction, we call that negative. You can think, negative people pull you down. Okay, and then we looked at this roller coaster again. Then we talked about 0 and undefined. So flat, like a flat line, that would be called 0 slope. There's 0 change. It's not going up, it's not going down, it's just 0, it's just flat. And then perfectly straight up and down, we would call that undefined. And that's just, you're gonna have to memorize that. U for straight up maybe would be helpful. Okay, so then I asked you to look at these rooftops and I said, how do the carpenters know how to match those rooftops? They don't have some magic wand that they can just, wave their magic wand and have those rooftops be identical. But in new home construction, in communities where new homes are being built, they like to have matching roofs. So real simple, the carpenters and the architects, they have a concept of slope. So now we're going to actually look at this rooftop and we'll see If you notice this rooftop, the direction of this rooftop right here, the steepness matches the steepness of this little roof. And then the steepness of that one matches the steepness of that one. We would say those are parallel. Well, how do the carpenters get them parallel? They don't just stand on a ladder and have someone like, okay, does that look good? Let me hold it right there. No, that's not how they do it. They use mathematical calculation to calculate the slope. Okay, so if you notice, let me back that up one more time. So I'm gonna travel up and over. So I'm gonna show you how to do this, and then it's easier to see down here, but then I'm also gonna show you how we can do it up and over this way. Okay, so we wanna make triangles when we're calculating slope. See this triangle that I just made right here? Because slope doesn't, even though the line is going diagonally, we don't measure the steepness by traveling diagonally. We measure the steepness by traveling over and up, or we can travel up and over. Okay, so the height of this roof from this point to this point, the height of this roof is 8 feet. Okay, so if I was to draw a triangle and I went over to this point and then straight up, this would be, excuse me, 8 feet up. And then the length of this triangle is 12 feet. Okay, so this is called a rise. This is rising 8 feet and a run of 12 feet. So there's a triangle right here. We can also make the triangle up here. So I'm going to go ahead and do that. So our rise was 8 feet. Okay, so I could travel 8 feet up the triangle, and then I can travel over 12 feet. Okay, and you're filling in your notes. This part's in your notes. So either way, you can do the triangle underneath the diagonal roof, or you can do the triangle up above. Okay, so either way, we're making a triangle. So this is a rise of 8 and a run of 12. Okay, so this we can simplify or reduce. So I can divide out a 4 out of both of those. If I take a 4 out, this is going to reduce down to 2 over 3. It's a ratio. It's a ratio, and this is how we would say it. We would say the slope of the roof has a constant rise of 2 feet for every 3 feet of run. Okay, so we took the 8 over 12, a rise of 8, and a run of 12, and we simplified that down to 2 over 3. So it's a rise of 2 feet for every 3 feet of run. Rise 2 feet, run 3 feet. Okay, and that's how a carpenter is able to match up, because if they know what this slope is, and it's usually on the architectural plans, the carpenter is just following the plans of the architect who designed the house. If this is a rise of 2 and a run of 3, a rise of 2 and a run of 3, then they can match that right over here, and they could make a little triangle on this rooftop as well. Okay, and that's how they would do it. Okay, they don't just stand there and then have someone hold the wood and say, okay, what do you think? Does that look good? That's not how they do it. Okay, so now let's calculate. Let's pretend this is like a rooftop right here. We can pretend this is a rooftop, and we're going to make the triangle to calculate the slope, because remember, we don't calculate slope by traveling diagonally. We calculate slope by making those triangles. Okay, so here we go. So our slope is our rise over run. So let's start with that rise. So I'm going to start down here, and let's see how far we travel. If I make a triangle, I go up. So if I started here, I went up 1, 2, 3, 4, right? So I want to get to this line. So I went up 4. So think of it like taking the elevator up 4 floors, right? If I'm here and I want to get over to here, I can't take the elevator diagonally. Elevators don't travel diagonally. So I'm going to take the elevator up 4 floors. The doors are going to open, and then I'm going to get out and I'm going to walk or run to blocks. Okay, so if you think of this is like I said, an elevator. I guess you could have a building that's like 2 blocks wide. That would be a big building, but they've got them. Sometimes buildings are that far. So I'm going to go take the elevator up 4 floors, and I'm going to get out and run 2 blocks. So that would be 4 over 2. And then we can simplify that down to 2 over 1. So for every 2 floors of rise, it's 1 block that we're going to run. Okay, so we're going to go up 4 and over 2. Or watch if I just go 2. I go 1, 2, and over 1, then I would be right on the line. Up 1, 2, over 1, and I would hit the line again. Okay, all right, let's try another one. So that's a slope of 2 over 1. Okay, let's see. Okay, let's try this one here. What's the slope of the given line? So now this time that you can see the line is traveling downward. And so remember, I said to you, negative people take you down. So our slope, when we're finished mathematically, it better be a negative number. So let's start here. We always read left to right. So I'm going to start here, but I can't travel down the line. I've got to travel vertically. I got to make my triangle. So I'm going to go down 1, 2, 3, 4, 5, 6, right? So I went 1, 2, 3, 4, 5, 6. So I went down 6. I took the elevator down 6 floors, and then I'm going to go 1, 2, 3, 4, 5. So since I'm going down, I'm going to make it a negative number. So down 6, and then I'm going to get out and run 5 blocks. I'm going to run 5. Okay, so down 6, run 5. And we always go, usually we always want to go either up or down and then to the right. When you get good at it, then you can start going the other direction and going left. But for now, we want to just go either, so in this case, we would go down and then to the right. Okay, and then that slope is negative 6 over 5. Okay, so that's by looking at a graph. It's pretty easy when you look at a graph. Just remember to make your triangle. Make the triangle. I could make the triangle going this way also. If I went 1, 2, 3, 4, 5, 6, and then backwards, right? So that's where it gets a little tricky because this is a negative. And if I went that way, if you're going backwards, it's got to be negative. Okay. All right. So more slopes from graphs. Let's see if we can calculate these. So if you were sitting in a regular class, I'd have you do it on your own. So you can go ahead and try it on your own. So there's no dots, no points. On this one, on the first 2, I gave you points. You could see where to start. But now I'm giving you graphs that don't have points. So you need to create them yourself. So I'm going to make a point right there. And we want to make points. If you notice this blue line, see how it crosses on the grid? Like it crosses right there, right on the grid. For example, like this one, it doesn't cross up on this grid point. So normally we want to try and look for something that starts on the grid, and then I'm going to use this one down here. So I'm going to start there. I was off just a tad. I'm starting there, and I'm going to go down 2 and over 1, 2, 3, 4, 5, right there. So down, here's my triangle, down 2, over 5. So that would be a slope. My y, on my y-axis, I would go down 2, so negative 2, so down 2, and then over 5. So it's a slope of negative 2 over 5. Okay, all right, now on this one, this is a flat line, so hopefully you remember what is the slope. Anytime a line is flat, it doesn't matter where it is. I could move the line, but let's see if we can remember if it's flat. Now let's see what happens with the math. So I'm going to pick that point right there. I'm at negative 1. And then I'm going to pick a point over here somewhere. I'm going to go right there. Now, I'm not going up or down. I'm only going sideways. So my rise my rise was 0, right? Because I didn't go up and I didn't go down. There was no rise. My rise was 0, and my run, I went 1, 2, 3, 4, 5, 6, 7, and 0 divided by 7 is 0. So this is a slope of 0, okay? Slope of 0. Okay, so now, so that was when we were looking at graphs. It's a lot easier when you're looking at a graph, but we don't always have a graph to look at. So now we're going to learn how to calculate the slope when they just give us 2 points. Okay, so for example, find the slope of a line containing these points. So the point 1, 3 and the point 4, 6. Okay, so here is what we call a slope formula, Okay, so it's y2 minus y1, and then here's your fraction bar over x2 minus x1. Okay, so you might be thinking, what in the world are these y2s and y1s, x2s, and x1s? So I'm going to show you right now how to do this, okay? All right, so we've got that. Here's our formula. And so these are the steps to calculating a slope when you have 2 points. So it says find the slope of a line containing these points. So we've got these points, 1, 3 and 4, 6. Okay, so here are the steps. They're right in your notes. So step 1 is we want to label the 2 points. Okay, so we want to label the 2 points. So we've got 2 points right here. So I want to just label them, and I want to call one of them point 1 and the other one point 2. So I'm going to go ahead and do that just like that. Okay. So that's step 1, is to label your 2 points. Step 2 is we want to stack the 2 points. Call this the stack strategy. So I'm going to take this first point and I'm just going to stack it. I'm going to slide it over and stack it right underneath. Now it's going to be a lot easier to look at. Okay. And then we're going to label these. So remember, this is point 1. So this would be my x1 and my y1, and this is point 2. So this would be my x2 and my y2. And we want y2 minus y1. Well, guess what? They're stacked right there for you, 6 and 3. So the next step in our process is subtract the y values on top. Well, I have them stacked right here, 6 and 3. So I'm just going to move those over and do 6 minus 3. I'm going to take, this is 0.2, and I'm going to subtract 0.1. So 6 minus 3 is 3. And now I'm going to do the same thing with the x values. I have them right in front of us, right here, 4 and 1. So we're just going to put those underneath. Step 4 is to subtract the x values. So 4 minus 1. And that becomes a 3 also. Now we have to simplify. So the last step is to reduce or to simplify. So calculate and reduce. And we can reduce 3 over 3. We could divide the top and the bottom by a 3, and we're going to get 1 over 1. So the slope of these 2 points, this is what we started with originally, it's a slope of 1 over 1, or we could just say 1. Okay. All right, I'll give you a minute to to finish filling out those blanks. So we want to label the points, point 1 and point 2. We want to stack the points. We want to subtract the y values on top, the x values on the bottom, and then we want to calculate and reduce. Okay, all right, let's try a couple more here. So the first thing we want to do in this problem here, we've got 2 points, -4, 2 and 2, 10. First thing we want to do is label them, point 1 and point 2. We want to keep track. Then we want to, we'll set up our formula here. We want to stack those. So I'm going to stack those. And now we can use our formula. We want the y values. So 0.2 minus 0.1, right? This is the y values. So we want 10 minus 2 is 8. And then we want the x values right here. So 2 minus -4. Now, you have to remember to subtract. Even though there's already a negative sign there, you have to subtract. And we've learned from the first semester what's a negative times a negative. Negative times a negative would be a positive. And so this becomes +4. So 2 plus 4 is 6. And now we need to simplify on that. So we need to change that. We're going to divide by a 2, take a 2 out of the top and the bottom. So we're going to divide by 2, so that becomes 4/3. Now I'm going to graph this really quickly so you can see this. Okay, so the first point we said was at -4,2. This isn't exactly at -4,2. I'm just showing you a point down here. And then this was at 210. And, oh, what I'm showing you, I'm not showing you these. Sorry, I forgot what I did. I'm just showing you the 4/3. So if I start here, I'm going to go up 1, 2, 3, 4. And then I'm going to go over, 3. So I'm going to go up 1, 2, 3, 4, and then I'm going to go over 1, 2, 3. And it's going to be right there. Okay, so there would be my line. So I didn't go through those 2 points, but that's okay. I'm just trying to show you what this slope looks like. It's a slope of up 4/3. There's the triangle, up 4/3. See the triangle right in there? So that's how we calculate slope. Okay, let's try the next one. We want to label point 1 and point 2, and then we want to do the stack strategy. Let's go ahead and fill that out. And then we're going to do stack strategy. So we're going to stack those, slide that over, do the electric slide. And now we want to stack our y values. Well, this is nice. They're lined up for us right here, 4 and 2. And remember, we're subtracting. So we want to go 4 minus 2. And then we're going to do our x values, -6 minus -2. Don't forget that extra minus sign. Okay, so we're going to go -6 minus -2. You've got to make sure you know what we're doing here, and it's this, -6 minus -2. Okay, and then here, these change that to a positive. So -6 plus 2 would be -4. And we can simplify that to -1/2. -1/2. Okay, I think we've got maybe one or two more, and then we're done. Oh, 2 more. Okay, what's that first step? First step is to label your points, point 1 and point 2. Go ahead and list out your formula. Then our next step is to do the stack strategy. And then we want our y values. So we're going to go 7, take away 7. That's easy, 0. And then -2 minus 6. And this is, if you play scoreboard, this is 2 to the negative team and 6 to the negative team. So they won by -8. So we have 0 over -8. And anytime 0 is on top of a fraction, we say it's 0. And so remember, what is a 0 slope? That would be a flat line. Okay, now on the last question here, they gave us 3 points. They gave us 3, 48. So 3 is dancing with 48. 6 is dancing with 96, and 9 is dancing with 144. But we only need 2 of those. We don't need all 3. So we're going to go point 1 and point 2. Okay. And then the next thing is to set up your formula. And instead of going 48 minus 96, because then that would be a little harder, we're going to go the other direction. So we're going to go 96 minus 48 and 6 minus 3. So 96 minus 48, that comes out to 48, and 6 minus 3. We don't even want to use this one down here because we're just using, we only need 2 points. This is 0.2 and this is 0.1. Okay, so 6 minus 3 and 96 minus 48. So 96 minus 48 is 48, and 6 minus 3 is 3. Now, we can simplify or we can just divide. We could divide 3 goes into 48. I like to think of it in simplifying, so I'm going to take a 3 out of both. So we get 16 over 1. And there's your slope, 16 over 1. Okay, so that's all you've got to do in those notes. Let me see if we're at the end or if we've got any more. I don't remember. I think we're at the end. Okay, so you've got one more thing that you have to do. You need to write yourself a tip or something that you're confused about. Okay, so in your notes, go ahead and write a tip for remembering how to do slope, or if you have a question, then go ahead and write yourself a question. Okay, and that's it. That's all we've got. So let me get out of this. Let me stop sharing my screen. And so we're going to keep working on this. That's just an introduction. So you've got part 1 and you've got part 2 videos. All right, and so we'll keep working on that. Go ahead and fill those notes out and then turn those into me, and you're good to go. Okay, all right, we'll see you. Bye-bye.